Good morning, team. Sorry, I kept clicking mute. Good morning, team. Good morning again, and welcome to the day two. We are ready to start our new part of the week, and today we have a little bit regarding storage. So first of all, let me say hi. Welcome again, folks. Welcome to our second day of class. We are starting our 2 hours of theory today. So it's good to see a lot of you back from yesterday's session. I know people will be joining in the next few minutes. So just a heads up, folks. Today we have a pretty entertaining class. I mean, we're going to talk about storage accounts, and actually that's quite an important module. But before we get started, folks, I'm going to stop the screen for a second because I want to show you the proposed solution for the session, well, for the lab that we were working with yesterday, okay? Remember that by the end of the week, I'll be sharing all these with you so you can have access to the proposed solutions. Remember what I said yesterday, this is not like the only correct solution. There are multiple options, but this is like closer to what we have. So let me get it here on the screen because I have it on a different monitor. Here it is. And let me just go here. Where is it? Study cases, study case solution. Here. So I have a lot of things here. Okay, so if you had the chance to go through the computing option, okay, and the governance option, let's remember that, well, there are a lot of scenarios, as I was mentioning yesterday, where we may be facing some let's say not complications, but that you may think, hey, this, I don't know how to do this, right? Or you just know how to create or deploy something, but you don't know how to actually manage it. So what I'm saying here, well, it's part of what we, yes, Adrian, is I have not changed the screen yet. So let me do that because, let me see here. This is done. The screen is being shared already, Sofian. You have to click on the start button that you have on the top left of your screen. So that's actually the one we're sharing, but just let me see here. Non-relational, application, authentication, governance, residence, networking. Okay. Here it is. Okay, so this is the networking. You should be seeing the screen with the proposed solution. So this is the computing proposed solution for those of you who took the chance to go through it yesterday. Let me just zoom out a little bit so you can see the whole screen. We have, if you were to the content, if you were to the whole content that we were supposed to take as homework, the computing part, you should have, well, let's say, got to the part where we were working on the solutions, right? The laboratory of computing. I'm going to show you the governance too, but the first one that we got for the infrastructure as a service solution, as you can see, it's based on one option. It's actually based on the 3-tier solution. Okay, so as you can see on my screen, you have the the VM scale sets being the front end with a facing load balancer to the internet. We have the middle tier, that is the one we use as interactive connection, and we have the backend tier that is only for the databases. Okay, so this specific solution that we have, again, as I said, I'm going to share this PDF file with all of you. You all will be ready to compare with what you actually did, but this is what we were like suggested to achieve from yesterday's exercise. Okay, now for the governance, you might remember we had a few requirements. We were supposed to use tags, we were supposed to use management groups and subscriptions with resource groups. Okay, so there were different options and scenarios for that solution to be there. I'm going to upload this into the drive that I'll be sharing with you on Friday for the exam, and you'll be able to have an editable option that you can use well to compare, to fit, and to have more options available on your solution. Okay, the idea of these solutions, folks, is that you start getting that knowledge about how to, let's say, use the best practices. I won't be tired of repeating, there is no correct solution. There is not only one single solution. Actually, take a look on the top. Other architectures may also work. So that's what I've been saying, and that's what I would like to repeat. This is just one option, a suggestion. Okay, this is an infrastructure as a service mode. Here we have a platform as a service in case we want to go a little bit different. Instead of using computing services based on virtual machines, we can use application services. We can use functions to trigger the configuration, and we can trigger the management via databases. Okay, so any of the two options is valid to meet the desired solution that we got on the requirement of the exercise 2. What we have to mandatory have is something to control the front-end traffic, the application gateway, and 3 tiers to make it work. Okay, front-end, middle tier from the communications and working roles, and back-end for the data and information. And that's what we have on our screen. Okay, so this is a solution for the second one. Let me see where is the solution for the first one. I'll feed it out on the break, and I'll come back with that. But in the meantime, folks, let me go here and start our presentation so we can actually have our day 2 running. So this is what we have today, my friends. There we are. Let me just put this here, and let me stop my camera for a minute so we can focus now on the screen. There. This is the non-relational data storage solution. This is today's module. It's a little bit shorter than yesterday. We actually always try to go for the 2 hours, so don't worry. If you have questions, issues, or complaints during the day, remember we have Joyce, our moderator, on the chat, well, on the question and answer section, answering back anything that you need. Okay, so don't feel like you're being ignored by me. She will take care of most of the questions, but as I did yesterday, and I always do, if there is something quite relevant to what we're discussing, I try to bring the question to the discussion. So we have a live answer and something useful for everyone. Okay, so what is a non-relational data storage, folks? First of all, we're going to design for storage. Okay, then we will see the storage accounts, redundancy, and we might talk about blobs on that point. Okay, we will take a break, as we did yesterday, and we'll go through the files. We will see how it works for disks when we have virtual machines. A lot of things about security. We will just discuss the starting point of the case study, and good to go. That's the plan for the next couple of hours of our day. Okay? First of all, data storage, folks. This is an important part because we have the understanding of what storage is, right? We all know what is expected when we say that we require a storage solution. But what less of us know is how it actually works, how it actually divides, and how it offers that option of usage. Okay? It is important that you remember, folks, that when we talk about the storage, we're talking about a solution to put our data somewhere, store it, obviously, implicit on the name, and then retrieve it on demand, right? How do we store our information? There are structures, there are semi-structured, and there are unstructured solutions for storage. When we talk about structured data, folks, we're talking about information that somehow is related to each other, and that relationship is actually registered on the same definition of the data. For example, a SQL database, right? Where we have columns, we have rows or entries on the columns, and each column might have a value that will relate it to another table. And then we start seeing how it looks like a big neuronal dependency, right? Table one might have 100 or 1,000 different dependencies through the whole process. So there are a lot of scenarios, folks, where using relational or structured data will make it easier for the end users, like us, to navigate through the hundreds or thousands of pieces of information that we have at once, right? And that's a reality, folks. When we go for the structured data, we make it simple to navigate, to understand it. But I'm not saying that it's the only correct option. We have a semi-structured scenario where we don't have a relational format, okay? We don't actually have that column that relates to each other, but we still have some structure. For example, if we create a repository for documentation like YAML, like XML, like JSON files, what we see or what we have in there is documentation where we can have our data, okay, structured the way we want it without that relational option. The data is still structured, okay? Because we have, as you can see on the small diagram, we have a JSON file or we have a descriptive XML. We still have some structure within the content, but hey, I don't have a direct relationship between them. And then we have the unstructured. That's the one we're going to refer today. When we talk about unstructured, it sounds, let's say, rude, or it sounds a little bit dramatic to say that it is the least organized because it sounds like something bad, but it is not bad, okay? When we talk about unstructured, there are a lot of scenarios where we have, for example, the need of dropping hundreds or thousands of files, right? How do we do that? We use the unstructured, folks. Just give me 1 second. Let me notify Microsoft because we're getting a question if we're running now. Here it is. Okay. So a recommendation I have, or a suggestion I have, folks, is that, and that's part of the core of this session, is that you analyze the needs that you have and always select the best option. Again, a lot of people will say, hey, the best thing we can do is create relationships within the data, so it makes it easier. That's not completely correct. Okay, so this is just an introduction on where we are and how do we plan for something. What we want, what we're going to focus on is the unstructured. Okay, first of all, we have storage accounts. This is where we start. When we talk about storage account, my friends, we're talking about a service that Azure provides to create a storage. Easy peasy. We're talking about storage, and the storage account is the one that gives that. The storage account, folks, is just the context. Let's remember this specific keyword. Creating a storage account doesn't mean that we have a solution that will store information. Inside of the storage account, we have to determine the service for storage. This is an important thing, and I always like to mention this first thing when we see storage account, because a lot of people think that the storage account will automatically create a storage vault where you can just start dropping information. No, the storage account is the service context where we will put the details of the type of storage we want to have. Okay, so let's be clear about that. We do have a storage account, yes. Can we store information inside of it? Yes, only, question for the exam, if we have determined the type of services and created the service container that we will store information inside of the storage account. I know it sounds abstract. I know it sounds weird, but you'll see it in a minute, and you'll see what I'm talking about. The idea of the storage account, folks, is to say, hey, what kind of information do I want to store? That's the first question you have to ask yourself, okay? You can have storage accounts with hundreds or thousands of different types of files, or you can have a storage account optimized for one single type of transactions, okay? There are a lot of different accounts. Ankit is asking what other types of accounts we have. We have service accounts. We have the word account. It's quite confusing because it could refer to a user account or a service principal or an actual service to perform actions in Azure. So we have a lot of different accounts, Ankit. Let me see if we can find something related to that. But we do have a lot. We do have a lot of types. But specifically for storage, that's the only thing we have, the storage account. Okay? Now, as I was saying, what would you like to store, my friends? This is the first thing you have to ask yourselves. I have worked with customers who wanted to have a location to upload their information. All the things they had on premises, they wanted to have a backup now running in cloud. We created a storage account. We had customers, or I have had customers who wanted to build a solution to create backups, just backups. That's a different type of account. I have a customer who wanted to log, okay, to have logs for everything. So it will have a storage account. We have a question related to the topic. Geoffrey asks, is network creation always required prior to creation of a storage account? The answer is no, Geoffrey. You can create a storage account without a network or without any dependency of the network after or before the service. Just remember something pretty important here, Geoffrey. And teamful for all of you. If you want to communicate with the storage account, you will need a network, right? You can communicate as a storage location, or you can communicate as a network service. We will see that on the next part, on the second part of today. So what I'm saying here is that it's not mandatory, or it's highly recommended. If you want to filter the traffic with a firewall, if you want to filter the traffic based on rules or location positions, or you want to use IP addressing for decisions, something I will show you, you need a network. After or before the creation, you'll need it. But it's not mandatory. It's not like you cannot create an account without a pre-existing network. Okay, folks? So that's an important one. So check the types of usage we have on the screen. We have the general account. You can put logs, you can put files, you can put pictures, you can put blobs, you can put backups, you can put hard drives, etc. Okay? In that kind of scenario, you have a general purpose account. You can optimize this for blocks, high transactions, pretty reduced latency, okay? Or a lot of small transactions. This one, for example, folks, the blob storage or data lake is used for big data, for a Hadoop analyzer, for an R analyzer, for machine learning, for an IoT hub, etc. The page blob that is at the bottom, it's also based on blobs, but this one, for example, is used for multimedia. If you're going to create your own streaming service and you want the lowest latency available and the fastest retrieval process for your users, the page blob might be useful. Or if you want to create a pretty complex logging solution, the page blobs might be useful. If you want to create an account for a premium file share where the users experience no latency or pretty reduced latency, and they have a seamless experience, like if they were directly connected to the storage location, you can use a file share, an Azure Files. I'm going to create one. Okay, I'm going to create a storage account and show you the steps. Remember, this is a design class, but I tried to give you some context on the platform so it makes it easier for you. But before creating the storage account, before I jump into the portal, I have to share with you, some considerations. The first thing is the location, folks. A common mistake that we all have gone through, and that I think it's one of the most common things that happen when designing, is that we design based on the management and not on the end user experience. And this is an important part because a lot of people, folks, will create a storage account and will put it wherever they are planning to manage it. For example, I'm on the United States. I go and create my storage account on the East Coast of the United States. But hey, my customers are in the UK. Is that the best option? The answer is no. Put the storage account and all the production services close to where it will be used. Okay? It is important that we have in mind that we are not the ones waiting for a response on an end user experience, right? If we put this in London, we can still manage it from the UK. We can still administrate the business as usual from the US. But hey, you folks or the team or the users will be taken care of directly in the UK, and you'll have a better experience than mine. Okay, so that's the first thing that we have to remember. Second thing is compliance. Remember yesterday we saw policies and we saw the option of creating role-based access control and granulation, right? Well, it is important, folks, that we remember that we are going to store data in here. It's not the same, and it's an important statement, creating a computer that temporarily catches information to process something than storing your customer's data, right? There are a lot of scenarios where you will keep data for months or years, and you need to be compliant to a lot of stuff. I've seen this happening a lot. You have a lot of security on the transit, on the process, on the analysis, but then you realize that your storage account is not encrypted, or that the storage account is accessible via public HTTPS. I'm not saying that's bad. I'm saying that might not meet the compliance requirements, right? That's why it's so important. The cost, I'm going to show you things about the cost. Just an FYI, folks. The cost varies from location to location and because of the type of disk. Okay? 1 terabyte on a standard hard drive will cost you, for example, $40, 40 US dollars on most of the regions, but it will cost you 130 if it's a premium solid state drive instead of standard hard drive. That's 3.5 times the price of a standard hard drive. It's a lot, right? It's a lot of money if we put the difference on or a balance. I'm not saying again that it's a wrong decision, but it's a thing that we have to include. The replication, folks, how do you want to replicate? We will talk about that at the end of today. The administrative overhead. Each storage account, folks, will require a setup. I'm going to show you that. Okay, so we need to consider that we might take our time to completely configure the storage account before even the first use. And finally, we have our security. I will show you the features of security that we have. So before we continue into designing for data redundancy, I'm going to start the creation of the storage account. So here goes my portal. There is my Azure portal. Remember that we have a delay of maybe 2-3 seconds between the screen and my voice. In some cases, that's normal, but it's just for you to know what's happening. So I have my Azure portal. I'm going to go here to storage accounts. I think they are somewhere around here. And here, folks, I'm going to hit create. Remember, you are not going to do this on the practice. That's the reason why I'm showing you a little bit more demos than expected, so you can have a visual support to grasp on the content and the knowledge. First things first, subscription and resource. We're going to use our RG we created yesterday. The storage account name has to be unique. Okay, so I'm going to go here and say SA demo 305. You can see I cannot use the hyphen. and I cannot use capital letters. The reason, this is not for all the names and services, okay? The reason of this one, folks, is because the storage account, once created, will have a unique URI or URL, and we will use that to connect via web. So to build it, it has to be based on something unique like this. Okay, there it is. The region, I'm going to use the East US. I always use this one because it's the one with the most permissive options in free trials. So it's not that I live there, it's just a matter of performance for my demos. And then we can create what I was mentioning. Standard, sorry, here, with general purposes, remember what I said, it's not optimized for anything. We're going to add a lot of stuff in here. We're going to put videos, we're going to put flat files, we're going to put backups, we're going to put virtual hard drives. That's fine. There is nothing wrong. Just be sure that you have configured this for this type of traffic. Or a premium one. The premium, folks, is optimized for a specific type of transaction. If I select, for example, file share, I won't be able to optimize it for multimedia, for backups, for large virtual hard drives. Okay? I highly recommend, folks, again, that's why it's a designing class, that you consider this before you create it, because if you create a storage account and you start using it on general purpose, there is no option to migrate into a premium version of itself without losing data. And that's not something we would like to go through, right? So a best practice, folks, is to have the storage account, selecting the best option from the moment of creation. Okay? So that's the next thing we have. Premium account type, file share, and there we are, or standard. Now, this is the first part. The next thing that we have is a redundancy. When we talk about redundancy, folks, we are using one of the options Microsoft has for you. Microsoft gives you the option to replicate your storage account capacity. Let me open back my chat. The storage account capacity, okay, to be used on different areas and regions. Ralph, yes, we have a question here that is important to the discussion, folks. Via templates, we can still use the version 1 account. Any reasons to still use that? One of the common reasons is to have backwards compatibility with some old storage management tools. For example, the storage management service, for example, the storage manager that it's now retired but still valid to be used without updates, or for example, an old SMB configuration, SMB1, SMB2. So if you still have some backward necessities, Ralph and Tim, you might still use version 1. But as you saw when creating my account, let me go back here, you only have, sorry, here, the version 2 account on screen. Okay, so that's the reason why. Now, let's go back here to where we were. When we're talking about replication, we talk about the options that Microsoft has for you, so your account and the data inside of it can exist in multiple regions or multiple locations at the time. We give by grant that you understand how the regions work in Azure. We have time. I'm gonna take 5 minutes to explain that because I'm assuming not all of you are familiar with this. Every region of Azure, folks, in the world, every single region is a compound of data centers. It might be 1, or it might be 5 or 4 different data centers together. We don't exactly know the amount of data centers per region. But for example, if you select UK South, you actually have your data center, one data center in London and a couple of other data centers around. Why is this important, folks? Because when we talk about data centers in plural, what we have is a dedicated building, okay, with dedicated network dedicated cooling system, dedicated power supply, independent from the others. Even though all the data centers together belong to UK South, we have redundancy within the data center. If one of these data centers fails, the others are still available. Okay? That's just for you to understand what's going to happen here. We can replicate our storage account to the same data center through multiple data centers or to different regions. It is important that we consider this a must, because after the creation of the storage account, folks, we cannot modify the replication in most of the cases. You might be thinking, okay, this is good. I should have this in my business as usual. If your storage account was there before, you knew about this, you might want to reconsider rebuilding the storage account from scratch and then just replicating your data manually for the first time. That's an option. Why am I mentioning this like this, folks? Because there are a lot of scenarios where you create a storage account and you don't know exactly what it means to have these replicas. Okay? So let me show you how you select it and what it means. Here we are. You have here the redundancy. You see at the bottom of my screen. We have local, zone, geozone, and geozone redundant with reading. Okay? Let me go here. The local redundancy will create 3 copies of the same storage account within the same data center. That means the building or the floor where the data center is. This will protect you against server failures, disk failures, or even a rack failure, right? You'll have copies maybe on the next floor or maybe even on the next rack, but you have your copies. This local redundancy gives you 11 nines of service level agreement. That's a big 9999. We can replicate based on zone. The zone redundancy, folks, is not available in all the regions. If the region has more than one data center on its facilities, it will actually be allowed to use it. Not all the regions have this. Okay? The zone redundancy creates 3 copies distributed through the whole list of regions zones that you have. This means copies in different data centers of the same region. So if we have 2 buildings, independent from each other, connected via network, we will have maybe 2 copies on building 1, 1 copy on building 2. If one of the buildings fails, but the region keeps running, my storage is still available. Okay? That's the zone redundancy. We have the geo replication. The geo replication, folks, will create 1 copy on your region you select, and up to 3 copies on a different region that is paired with yours. The region pairs are usually 300 miles between each other. That's roughly 500 kilometers. 500 kilometers between them. So if you use UK South, for example, this might be created in UK North or North Europe, the one in the Isle of Man. So it's useful, right? It's useful to know that I have enough space between my replica. If the region fails, you have your copy 500 kilometers from the original one. Okay, so that's one of the things that we have. And there is an option, not available in all the regions, where you can actually have geozone redundancy. You have 3 copies Distributed, yes, that's the yield, the one that goes depending on the pair geometry. I'll take that one in a second. The GeoZone redundancy will create copies in different data centers of region 1 and copies on different data centers of region 2. Okay? So in this specific scenario, folks, what you have, it's the option of being protected against hardware failure, data center failure, region failure, and you still have your available copies for you. Remember, whatever has a Z, a zone, it depends on the data, on the region having multiple data centers. Geoffrey is asking if we have the local copies and the remote region for the geo redundancy. Yes. What I meant when I said that we can get up to 3 copies remotely, besides the ones we have locally, like we do in any scenario, is that we can use a manual replication to that region to extend the geo replica. Again, by default, we have the 2 regions, one with the local copies and one with one single copy remotely. But we have the option of escalating this if we want with a manual replica to complement with 2 more replicas or more copies on the secondary region. But that's not a default option. That's something we usually call for on our own. Okay, so important. If I don't select any or I keep it local right now, I might not be able to change it. 99% of the times you won't. There are a few exceptions based on the type of subscription and a direct Microsoft request. But in most cases, folks, that won't work. So now that you understand how we replicate, the next thing is to understand, okay, which one will I use? Consider that the cost of per storage and the cost for transactions might vary because of this. Okay, so that's the first thing. The second thing we have is a little bit about security and a little bit about other options. For example, we're going to create blobs after the break. We're going to create objects after the break. How am I supposed to access those objects? For example, if I create a storage account for backups or for multimedia, large amount of information in a few files, right? 2 files, 2 movies, or 2 video files with 8 gigabytes each. That's big. I mean, for storage purposes. How am I allowing the consumers to interact with that image or with that video? Am I actually letting the users access without an authentication? Or should they have an actual authentication for that? We can enable that kind of options. Do we want this to be exposed to public accesses or private accesses? Are we going to use SSL 1.2? What TLS version do you want? By default, question for the exam, we have 1.2. So what we're doing here, folks, is selecting, okay, what will be the next, like the options that we will give for the consumption of our information. We can optimize this storage account to be a data lake, as I said, for big data. If we want to use Hadoop, if we want to use Spark, if we want to use R, we can make this storage account optimized for those solutions, just like this. That might not be the case. That might not be something you want. So it is important, as I said, that we have consideration of the expected life cycle of the storage account, because we may say right now, hey, I don't need this. But what if in the future we have a security gap and we need to modify something? Don't worry, this can be changed later. But we have to be sure of what we want or where we want to be. Okay? The networking. We got a question, remember earlier today, about we requiring an IP to be there by default. The answer, as I said, is no. I can create this storage account without a network. Okay? I'm going to explain this on security, so hold this one, the network access. I'm going to explain this on the final lesson of today. So I'll come back to this one later today, and I'll show you. Okay? So it's just hold that one, because we can change this later. And we can select how it routes. This one is a little bit of a tricky concept, because we need to understand how Microsoft routes the transactions. Microsoft has 2 options, okay? We can use public routing or we can use private routing. The public routing uses the internet. You connect, and your traffic will travel through internet connections. To navigate through the world or across the world, it will use internet connections. That's it. When we use Microsoft traffic, we use a dedicated backbone Microsoft has for you. Okay? This dedicated backbone that I'm mentioning, folks, usually it's a combination of all the data centers and edge points, they have around the world talking to each other with dedicated circuits. So we don't see that traffic. Okay, let me show you here quite fast. But I need to use Chrome. I have a thing there with my DNS, so that's a personal thing. Microsoft backbone here. It's Azure backbone here. Where is the map? Is this one? No. Yes. Let me find the map, because there is a pretty amazing map that we can use. I was thinking, here it is. Okay, let's wait for it. I just want you to see the map, because everything we have in Azure, Microsoft 365, Dynamics, CRM, ERP, all the things that we use in cloud provided by Microsoft are connected together. Everything is connected here, okay? And well, we will wait there for it to open, but the idea is that we understand that we'll be back here in a minute to see if it's running, but whenever we select Microsoft, the traffic between my storages, my networks, my virtual machines, whatever requires to get into the storage account will be handled by Microsoft Backbone. It's not a public traveling request. Okay, so it's actually taking a while there to open. I don't know why. I'll check this on the break, and we will be back on this one. Okay, so we can select how we reach the storage. Okay, especially consider this one, especially when you're talking about remote work. You might be working in one country or in one continent, and your users, consumers will be a different one. So we need to be sure, how are they reaching out to my storage? Okay, that's another thing that we have. We have here some data protection, folks. The storage accounts will give you, by default, the option of protecting your data from accidental deletion. Okay? If you perform something and it accidentally tries to delete your information, you'll have confirmation options, you'll have a validation period, you'll have a default retention in most of the cases. But you can configure this to be more or less. The soft delete for information, for file shares, for blobs, for anything, it's by default 7 days. Question for the exam. If you are asked to design for redundancy and for recovery, this is one of those values that you might need to reconsider. Okay? How much time I may need to have my information available? Important. This is not an easy answer, because this also has an impact on the cost. You pay per gigabyte, folks. Per gigabyte stored in your cloud. So if you keep this for 30 days and you're deleting terabytes, that's a big deal. It's not the full price while the content is in soft delete mode, but it does has a cost. Okay, it's actually costly. Well, not as costly as a full live session, but it has a cost. So for example, if you have a terabyte, you delete that for a month. At the end of the month, you'll pay for the terabyte that you still have online, and you'll pay a portion or a fraction of the terabyte you have in soft delete. So if you don't consider this a must, then my friends, reduce it. Maybe keep it on 7 days or 5 days or even 1 day. A best practice of design is to always have at least 1 day of retention before permanently removing it. That's just a recommendation for designing. Okay? This can also be changed later. We can enable here a versioning. Remember, the versioning will actually create and save old versions after the modifications taking place on the storage. This has a similar consideration than the soft delete, folks, because you might be retaining, you may be creating versions, and you will realize that you're paying more money for the same file. And the reason behind that is that the same file has now two versions. If the file is 1 terabyte and you're keeping 5 versions, you may have 5 terabytes of cost for one single file. Okay, so that's another thing. I know this sounds amazing, right? Like, hey, I can finally track down the modifications and avoid possible issues from happening because of a malintention or an unintentional modification. Yes, but again, this goes into the price. Okay, and we can enable here an immutability support, so our retention policy will determine for how long a file will be immutable. Okay, so there we are. We're gonna go here to encryption. By default, we use Microsoft keys. Important question. Can we actually bring our own key? Yes. We can create based on key vaults, and that's a discussion you'll have to work on your homework because that's a topic that we don't have during the live sessions, but you do have it on the learning pad. We have the chance of creating our own keys and bring it here to encrypt with our own key. Microsoft states on the privacy agreement that if you use your own key, they don't have access to that, and they don't actually use your own key as theirs. Okay, so it's a thing to consider. Question, can I change this later? Yes. If you leave this with a default Microsoft key and you bring your own key later, that's fine. We can do that. Okay, what would you like to encrypt with your own key? Blobs and files or everything? I will go for everything. Important, if I enable the infrastructure encryption, this is an encryption at hardware level, I won't be able to modify this later. My storage account will have logic encryption based on my key, or digital encryption, if you will, here, but also a hardware level encryption on the server using this one. Why would you decide to not use these, folks? There are cases and scenarios where you realize that using hardware encryption might complicate or even disable certain types of activities, right? For example, rapid hashing is not allowed because it's considered a past the hash. So it's a possible type of attack. I'm not saying it's wrong. I'm saying that, hey, if you're going to go for this type of usage, just consider that it might have an impact, okay? So I'm going to leave it like this, and we can encrypt it later, but it won't be able to be decrypted again after that. We go here to the tags. We saw this yesterday. We review. Let's complete the validation, and we hit create. On a real scenario, folks, this might take you, I don't know, 10 minutes? If you had a proper plan before the configuration, it will be easier for you to decide what options to select. The options that I've shown here, folks, on this demo are actually there for every single time that you create this, that you go through a subscription, okay, through a storage account subscription creation. It's pretty straightforward, but remember, folks, we have it here. We can go here to the resource. There's a storage account, but we don't have yet any of the solutions that we mentioned that will be used to store our products. Remember what I said. The storage account is a service context where we can create storage services, you see here, to put our information in cloud. I cannot upload anything yet. I cannot drag and drop unless I start configuring the storage services. Okay? We're going to go through the storage services on the second half of the session. We're going to take a small break so you can stretch the legs, and we can balance the times. Folks, something important I would like to mention, not all the days we will have a long break, okay? Tomorrow we may have just 5 minutes or something because we have more topics than today. So again, it's just for you to know why I do it like this. And as I said, not all the classes have breaks, okay? Don't think that if you're taking a break here and you are on another track registered, it's not actually be the same. It depends a lot on the type of content that you cover. Okay, so any questions so far, folks, please let us know on the Q&A section. We're gonna have a small break. Let me go here. Put the timer on the screen. We're gonna have 20 minutes, no, I'm crazy, no, 10 minutes. Just so we can balance the time. And well, you can stretch your legs, get some coffee, get some water. We will start after 10. For the second half, there are the services, the connectivity and security, and the wrap up of our day 2. My friends, thank you very much. Talk to you back in 10 minutes. Welcome back, team. Welcome back. We're going to continue where we left. So we have the storage account now, okay? We have created the context service that I mentioned, and we're ready now to start adding storage services on it. The idea is that we can have our products now storing, right? That's the actual core of the business, to be able of storing some information where we need to. So the first thing that we have, folks, as you can see on my slide, it's the usage of blobs, okay? We're gonna build a blob storage account. Well, the storage account is already there. We're gonna put a blob service inside of it for the sake of storing. First of all, remember that blob stands for binary large object, okay? We can have, as the name suggests, large objects that will have hundreds or thousands of pieces of information within, for example, as I already mentioned, backups, multimedia, databases, virtual hard drive, logs, that's pretty common, etc. We can have, on the tiers, check the tiers that we have, the first column, we can have premium for heavy throughput, okay, with hundreds or thousands of operations per second. It's the highest cost per storage, but the lowest cost per transaction. For retrievals, read cost, okay? The premium tier, folks, it's recommended for live consumption. As I said, a streaming service. Or for example, a pretty common scenario, if we want to have a global virtual hard drive for my users, for my computers, instead of replicating hard drives on each of the computers, we can use one single location and put all the computers to read from it. That will usually have a higher demand, right? Well, we can do it like this and bring our blob to a premium transaction mode. This is one of the most common scenarios we have, okay? Important, and this is something I would like to mention. The premium mode can only be achieved if you selected premium when creating the storage account. Remember? Remember that the first page of the creation had a premium option for blobs? If you didn't select it there, you won't have premium available in here. Okay? We can go for standard, the standard hot. Hot, my friends, means that we have a balanced storage cost per gigabyte, but a little bit of a low or more expensive, if you will, retrieval cost. This is the most common scenario for any production requirement. I think 90% of the times when we want a blob for production, not for backup or retention, we go for hot. Okay? When we go for cool, is because we're considering that we may have one single access per month. For example, a monthly report backup, or for example, a KPI that you run every month. In these cases, using the cool mode will reduce the cost per gigabyte, will increase a little the cost per transaction, but since you're going to have few transactions in a 30 days or I don't know, 20 days period, it balances itself. This usually, as I said, is used in short-term retention. And then we have the archive mode. The archive mode, my friends, is the cheapest per gigabyte, but the most expensive, per retrieval transaction. Important, something pretty important in here. If you go for archive, your information will be dehydrated. That's the term. It means that your information won't be online. You will have to wait from 2 hours to 5 days to retrieve the information and use it. Do not use archive unless you're sure that there won't be any possibility of you requiring the information immediately. Okay? This is a pretty important one, folks. A real example. Back in 2012, we were requested by the UK government to put all our collections data or related to collections data, let's say outstanding balances, messages, calls, etc., in a long-term retention for 10 years. They wanted, or they needed, not wanted, they needed us to have the information retained for auditing and obviously compliance purposes, right? So we didn't have back in the day, well, we didn't have Azure, but we were starting to use it, and we didn't know what will be the best option. And after a few months, we analyzed the option of magnetic tapes, we analyzed physical archiving and stuff. The cheapest option was this one. It's pretty cheap, folks, per gigabyte. And we were told actually by the government that if in case of needing the information for an audit, we will have a 2 weeks announcement. So we will be informed that we were gonna need that information with 2 weeks of announcement. So that was enough. We went for archive. I come back to the UK 3-4 times a year to visit family, and every time I hang out with my ex co-workers, now friends, we have that joke of, have you used the archive? They have never used it. I left in 2016, and they have never used it. They have paid, just to give you some ideas, like context, they have paid like, I don't know, $300 since 2016 to keep their terabytes of data stored in archive. I mean, it's a pretty specific example, but this will make easier for you to understand what is this. Let me show you. We're gonna go to the blobs now. Here. Where is my blob? Here. And here it is. Okay. So in here, folks, we're gonna go to containers. That's where the blobs are. We're gonna create a new one. You can see by default we get one for logs. This is always there, okay? It's a default creation of a storage, of a general purpose storage account. I'm gonna click on container. I'm gonna call this, let's say, blob container demo. And we have something for the access. What is this, folks? This is important. Let me explain this because this is part of your design. Let me open your paint. I use this as whiteboard. So we have, we have this as the storage account. Okay, this is what we just created. So this is my storage account. Inside of my storage account, I'm gonna create a container, right? This is my blob container. Here, let me just, there. Inside of the blob, folks, or the container, that is the one we are creating here, we have the actual files or blobs, okay? So we have our file in here. That's good. Now, I can enable the access to be private to the blobs or the containers. This means that I can expose this for external users, folks, to read without authenticating themselves. At this level, and all the containers, they can read that, or at this level, and only the files inside of the containers. This is an important decision to make because you might be storing information that you want to be publicly accessed and where people, users, consumers might not have the option of authenticating. So a private access to all the blobs and containers or just the files, it's considered, okay? This can be changed later and you'll be able to select it per container. So I can do this and let users access anonymously. Or I can keep it private and change it if I need to. Okay? There we go. We have the container now. I'm gonna open this one. And here, folks, we have now the blobs. We can upload any file to be stored as a blob. Let me see what we have here. A friend of mine just passed away last night, so I'm going to use his picture, his memory. So here goes. I upload a picture, okay? So you can see that by default, I get a hot access tier, right? This hot access tier, it's granted to this specific file. If I upload a different one, let me go here to a different one, use this one. It's also a default hot access tier, but we have the option of changing the tier of each based on my needs. I can grab here, for example, the first one, change the tier on the top, and move this into archive. This will be completely blind. Okay? I can click on save, and there it is. It's an archive just like that. So this is an important thing, folks, because you may have a premium blob for live services and stuff, but that doesn't mean that all the information you have on the container requires the same level of access, right? As you can see here, I'm putting this on archive, and that's a common practice. To bring it back online, you can see the size. It's pretty small. If I click rehydrate, and even on high priority mode, folks, it will take hours. I can bring this back to hot, rehydration, high priority, save, at least 30 minutes, at least. And I'm talking about because of the hour in the United States where my storage is located. You can see it's 4:30 in the morning in the United States. So that means that there is not a lot of traffic because that's where I created the storage account. Even though we're talking about that, this is gonna take at least 30 minutes for something of this size. So again, use the archive when you are pretty sure that you won't need that immediate access to the information. This is a blob service, folks. Now, the blobs have an option where we can create policies here to create immutable management. An immutable storage policy, it's usually recommended to have healthcare, right, of your organization. The idea is that the data that you have in the blobs, it becomes immutable, and no one except the owners or the admins will be able to override those policies. You, my friends, need to determine if your organization will require this immutable policy. Why? Because you might actually want to go here and say, hey, I'm going to put a time-based retention. No one will be able to read or write for the next 30 days. We're going to an auditing process, and there are no changes allowed until we have the result of the audit. That's common. Or hey, we are under a legal investigation. That's a pretty common scenario, right? You provide information as legal evidence. It's on a legal hold. As long as the legal hold remains in there, the blob becomes immutable. You don't have to say, I think the legal retention will require to be there for the next 10 days or for the next year. You might not know. But you can put a legal hold without an ending date, an expiration date. Check this out. We can add here an access policy and say, hey, you can only read, let's call this, for example, read only, starting today and ending up on, let's say, a week. You click OK, and this is a read only. If we add here an immutable policy of no modification, you can see here time-based retention, 7 days. You can click on save. Both are nested together. Immutable policies have permissions or override whatever you add on the access policy. If I have a read and write permission in here, but I have a time-based retention in here, this one overrides this one. If I try to modify it, I will be able to, because I'm the global admin, the security admin, the owner, and I have all the permissions. But for regular users who come here, they won't be able to do anything. That's the idea of this policy. Okay? The recommendation is that you have read-only or read access permissions limit by the access policies on each of the containers. These rules apply only for this container. That's the only container affected for what I'm doing. Okay? So that's a good thing because we can granulate how the users access and interact based on different types of containers without compromising anything. Or we might create a global access policy and use it or replicate it as a template in multiple containers at the same time. That's up to you. Okay? So this is the next option we have, the blob. What other services we saw? If we go back to the storage account, here, we also have file shares, queues, and tables, right? On the file shares, folks, for example, we can create advanced Azure files that it should Ankit, but a best practice is to have less than 5 global admins. So you can use role-based access control and access permissions to avoid the global admin from doing something like that. Okay, Ankit is asking if the global admin shouldn't also be affected by the policy. The answer is yes. At least from my standpoint of view, that's a correct statement. Why it's not there yet, I don't actually know any like specific reason for that to happen. Okay, so it's just a consideration. Now, if we continue here, folks, if we go now to the next storage solution or storage service within the storage account, we have the Azure files. Okay, the Azure files, my friends, are options or are services that we can use for specific cases like network attached storage replacement, like lift and shift migrations, anything that requires a file experience or a file management experience for you, the admin, and for your end users. Creating a file share, folks, it's pretty easy because if you go to the storage account creation and you select premium for file shares, the only thing you have is a file share. On my example, on my general purpose example, I have to explicitly select the file share to be deployed. Okay, so I can go in here, I can click on file share, and I can select here what I want to create. Check the difference. We don't have an archive in here, but we have one more option for advanced transactions. Okay, in this specific case, for example, if I select transaction optimize here, I have, you can see, my ingress and egress rate. Important, folks. It is important, or it is relevant that you remember that on control of the blob, the whole file share will use the tier. Okay? If I go here and say hot, everything I put on the file share will use the same tier. I cannot granulate and segregate the way I did on the containers. Okay? Pretty important. So I can have it here, for example, a hot and create. I have my file share now. Based on what you want, the options of selecting one or the other is based on cost efficiency or on the workload management. Okay? A file share, folks, can be a little bit harder to determine the tier because since we have the same flat tier for everything, using a high throughput, for example, using a premium tier or a top tier, might actually impact more on my cost than on my actual experience, right? Your users may have a pretty good experience that won't be that different if we had premium or transaction optimized or even hot. Again, there is no best practice in here. There is no correct answer in here, folks. You have to consider what the users need. Where are they located? How many transactions you have? How many files you use? How often they access them? And based on those questions, you can actually determine which one will be the suitable option. Okay, so I have created here my object. I can create a let's say hierarchy based on folders. I can actually add directories and folders. For example, we can go with root. Then we can go inside and add directories. For example, let's say IT. And add here BI. We can go to IT. We can add one and say, I don't know, backup. I'm just throwing some names. Okay? Then you'll see that you have now at least a folder or a directory navigation option. This is good because you create or you simulate a regular experience of a network attached storage, or a storage area network that your users might have. I can go here, click on upload, grab my file, put it there. You see? I have my file inside of the file share. Now, my file share, folks, if I go all the way back to the file share, still follows the same principle I had. If we go to the top option, we can connect. If we decide to connect, check this out, we can connect Windows, Linux, and Mac OS. If we connect, folks, we will be capable of using, if you will, information that might be useful, that might have a proper representation for the end user to experience a seamless experience compared to a network attached storage. If I run this PowerShell script, if I change this, for example, Y, and I run this script on the local computer or the virtual machine, it will connect to this and we will pop up as a network location, as a network attached storage. The users won't actually know that they are not accessing a local network service. They will have a complete seamless experience for this scenario. Okay, so I can grab this script, run it on my computer, and connect it if needed. This is useful, folks, because you can create that private intranet experience or intra-file experience for all your users. Okay, if we decide that the capacity of the file share is overloaded, we can change the tier, go to something faster, or go to something slower. Again, for everything inside of it. Okay? So we can do this with the file share. Now, we have the option, if we want, folks, of creating snapshots of a file share that will be immutable, on contrary of the immutable rules of the blobs that we saw on the previous demo. On the file shares, we cannot create those immutable retentions. On the file shares, folks, what we can do is create a snapshot that will catch whatever we had at the moment of the image and use it for readable permissions. I can create a snapshot here. There, app snapshot. I can add this as demo and create it. I can see the snapshot, and you can see the same structure. You see? Root, IT, backup, and there I have my picture. But on contrary of the real file share, my snapshot, folks, that I have here, it's completely immutable. I can open this and check this out. I can also connect it. So when we are designing, folks, and we're thinking about long-term retention, balanced accesses, etc., using snapshots might be the best, or could be one of the best options you have to reduce the possibilities of malintention or unintentional changes. The same as with the blobs. Again, the difference here is that we won't have an option to determine for how long. And whatever change I perform on the source material, the real file share, won't be replicated into the snapshot. The snapshot will remain with the information we had the moment we took it. Okay? So my recommendation is we analyze the option of the snapshot. And the snapshot also has a price, obviously, that comes based on the amount of information we have of it at the moment of creation. Okay, so that's another option we have here with the file share. We can go back to my services. You can see no snapshots here. Okay, you can. We have a question related to the snapshot that it's important, I think, to mention it. Chandrasekhar is asking if we can restore the files from the snapshot. We can do it manually. Okay, or we can use a scripting tool like PowerShell or CLI. It's an option, but there is no direct button here that you can use. Okay, so I can grab my snapshot. You can see here. I can like download or something, or I can restore one by one. I can restore my file. I can restore my folder, but there is no button like on the top or something. Or we can execute, as I said, a script to restore multiple snapshots or multiple versions. So yes, we can use it like that. Okay, but important. Check this out. If I go to my file share and I delete the share, you can see here it goes with the snapshot. Okay, so be careful because you can use it, for example, for protection of unintentional deletions or something. But in a lot of cases, if someone delete the whole file share, we're done. There is no backup, at least no from the snapshot. That's something I wanted to mention. The file share is the only storage service in the storage account that can be backed up on a backup service. The blobs have to be manually deployed. Okay, the snapshot is within the service just as a one-time image, and the backup is actually live on a different location, on a different region, on a different service, stored for a continuous management. Okay, so we can actually call the snapshots a one-time image inside of the object while the backup will be on a storage service. Okay, so it is important, I hope that answers the question, Max, that we know that the snapshot is here. I took a picture of my object. While if I go into my backup service, the backup will be created on a different resource called the backup vault. And the vault will control the backups in different regions, with different schedules, with different timestamps, with multiple versionings, with long-term retention. So the backup is a full backup service. Okay? And this is something I wanted you to see because, this specific part is not on the exam, but I think it's important you know when you are designing that you can go for a full backup. We will see this demo of backing up a file share on, I think the last day, on Thursday, yes, on Thursday, when we go to disaster recovery and business continuity. We will use the service vault to connect to the snapshot, to the file share and retrieve it. Okay, but that's what we have on these two folks. These are the options for the file share. The blobs, in case you're wondering, will have to be manually replicated using a script or using an automation trigger to happen automatically without human dependencies based on a timestamp, based on a trigger, based on a manual execution. Okay, so this is my file share. We have now containers and file shares. Before I continue to the official content or the slides, I would like to mention that we also have queues and tables. This is not an exam. This is part of the 204 AC400 because we use them more for that kind of management, like programmatically. But let me just mention here, the queues, folks, are message managers that we can create to decouple services. We can put a queue to connect a front end and a back end and use the queue to handle the messages between them both. For example, I can have a queue to attend online petitions of an application, catch the requests without overloading the backend application, and then just send the whatever was received on the queue to the application at its own speed. The queue is a flatline queue we can use to store messages and then share them with the destination. One input, one output, that's it. Okay, that's the queue. And the table, folks, the table is a semi-structured option. Imagine an Excel file without the Excel front end. You have rows and columns. Okay, the table, folks, will help you to add, for example, indexes, for example, pointers to anything that needs it. A real example so you get a functionality. I have a customer who created a lot of custom attributes for the Active Directory. The Azure Active Directory has no many attributes like on premises. So they created a list of attributes they use for their type of business they have, and they put the attributes on a table using a like a main identifier, the object ID. They can retrieve attributes that otherwise won't exist for their users in Azure. They have a table here, and that's it. It's pretty straightforward, and it makes it easier for them instead of creating a third-party identity management. That's an example of a table. And just for you to know, in case you were wondering, because they are here, but not mentioned on our class. Okay? So these are the containers, the file shares, the queues, and the tables. Now, another functionality that is not like visually available in here, because you can see we have a lot of different things, configurations and stuff, but it's not actually listed in here, folks, and that's a weird thing, is that we can use the storage account. Actually, we do it even if we don't want it, for disk storage. When we create a virtual machine, the virtual hard drive or hard drives that we assign to the computer are actually stored in a storage account. By default, this is a hidden storage account on the backend that we don't actually use or we don't actually work with. That storage account exists to have our disks available for the computer to be used. There are different types of disks that we can get. The virtual machine can get from basic to advanced disks. We have from pretty standard disks to ultra disks that might be quite fast. Remember what I said. The difference between one and the other is quite a lot. The basic standard hard drive, $40, $40 a month for a terabyte. The premium standard, not even the most expensive, is 135. Not all the computers nor all the regions can have ultra disks. Okay, there are specific scenarios where we can use for heavy throughputs on the case. Once you have your computer, folks, let me show you. I think I have one. We should have one at least. Yes. We don't actually know, well, at least not by default. I don't know where my disks are, but I know I have disks, you see? By default, I got an operating system disk. If we start adding disks, folks, here, you can select the type of storage you see. You can see, remember the redundancy? The redundancy is given local because of the way the storage account was configured. This, my friends, is the default configuration of the account for the disk. Okay? But in some scenarios, I mean, especially if you're going to share disks, for example, this data disk will also be used by other computers. You may be in control of that inside of your storage account. Okay? So this is an important part. We're not talking about computers here. We're talking about the storage needs of the computers. And a lot of times I've seen, and this is common, users creating new disks and new disks and new disks, and then replicating information to the existing disks. Instead of creating one single storage solution, putting a single data disk in there, and then instead of creating, attaching the existing disk. Okay? This is a best practice. When we design, folks, we're going to have reutilization of the disk. The best practice is to centralize the disk storage into a managed storage account, yours, not the Azure one you get, for example, for this one. And from there, start working. I can see my disk in here. You can see the basic configuration. You can see it's not shared. It's actually configured as an on-demand connection. And on the overview, you can see here where is created, here. Where is located, here. It's managed by my computer, okay? So I don't actually see where it's stored, you know? We can change this, not for this one. We can change this for the data disks that I'm gonna share on my computers. So it's a recommendation. So my disks are also part of the storage, right? Maybe not exactly the same as the other, but it's one of the options that we can have. Okay. I will suggest that you take a look at the disks of the computers you might be using, because there are some cases where a single data drive might be needed, some cases where multiple data drives might be needed, right? So this is our disk solution. We have a question related to this topic. You can have one data disk for multiple computers. Yes, consistency, Max, consistency is the main word in there. Like I have data consistency, and I know whatever I change that multiple business processes or users might need to know or might need to access will be consistent through all the different endpoints that interact with that information. So in that example, where you have, I don't know, the same source for multiple applications or the same source for multiple front ends of the same application might be completely consistent. Instead of replicating and hoping that you have a real-time or close to real-time replication, you have an immediate committing of the transaction, and then you have consistency for any other consumers through the network or through the computers working with the disk. Okay, so that's an idea of why you may have one disk for all. Okay? And I think this is the final topic. It's going to take us a few minutes, so no worries, we're good on times. But one of the most important topics of this lesson, folks, is the security part. When we talk about security, folks, we're talking about different features and different characteristics that will make our storage account safer. Remember, I would like to be quite clear about this. There is a dedicated 1, 2, 3, 4, 5, 5, 10, 15, like 20 to 23 days class for security, divided in different classes. Okay, it's like a long security path with 5 different security tracks. 1, 2, 3, let's see, 100, 200, 300, 400, 500. Yes, 5 different tracks. I am mentioning this because what we're gonna see here is just a foundation of security when designing the storage account. So we know what can we have if we want to or we need to. Okay. The storage security, folks, refers to different topics. How do we access? Where are we coming from? And how do we manage that access? Okay. There are a lot of different points on the security. Networking. How do I get to my storage? Is it publicly accessible? Is there a filter or something for specific IPs? Is there a conditional access for specific variables of the connection request? Well, once you have the access, how do you get the permissions to interact with the account? How are you granted or denied from permissions for how long? And then, are we hiding the storage behind an endpoint So it's only accessible via private networks. For example, on this third option, we will need the network we mentioned earlier today. I think it was Geoffrey who asked. Do I need the network for an endpoint? I'm going to show you this, okay? Don't worry. What I'm saying here, folks, is that the storage account has a lot of different options of security. From external connectivity to privacy, it's important that we understand a lot of other services to secure my storage. It's not as easy as it sounds. I mean, it's not like security you have within the storage account. You need other services, but it's good. Let me show you. First of all, the access policies. We're going to go here to the storage account again. We're going to scroll down to security, and we have our options of security. First things first, our option of access. How are you guys on the call, how are you going to access my storage account? It's a rhetoric question, don't worry, but I'm just like giving you the idea. I can expose my storage account via shared access signatures with a unique URI that if you have, and you have the proper key, you can use to read or write. This is the first security feature we have, and I need you to catch this quite clear. A shared access signature will let you, the user, have an access for a specific amount of time with a specific scope and a specific list of allowed actions. We can granulate as many shared access signatures as we want, create as many as we need, share them with the users, so a lot of different levels of accesses are granted simultaneously. Nevertheless, the shared access signature is not considered a long-term solution. The reason is that if I create a shared access signature now, I go out and I come back, I don't have, at least on the portal, an option to retrieve the old shared access signatures I have created. It's gone. Okay? So that's an important one, because I can go here and say, you're going to have access to the blob that I created where I have my pictures. You will be able to read only the objects. Remember, the start on my paint. So like this. You can only read the indexes starting today and ending up today in 8 hours. You see, it's a short-term access. You can increase this. The longer you keep a shared access signature, the more probable is that you get under attack or the access gets compromised. Best practice on designing security, folks. Use this for less than 7 days, or 7 days stops, 1 week. I'm not saying that's the default limit, or I'm not saying that's the actual limit. You can use this for more than that, or longer than that, but it's not a best practice. It's actually pretty important that we consider this like not a recommended safe way of sharing the access. But we have it. We can select the type of protocols I'm going to allow. Remember that we can have different routings if we enable them, and the signing key. I'm gonna show you the signing key. So I create one, and you have now the connection string, the token, and the URI. You see? If I share these three pieces of information with you, you'll be able to read the image I uploaded via internet connection. If I go out, let's say that you have two admins, Joyce and myself. Joyce creates this, and then I come to the storage account, and I want to see the signatures. I cannot do that from here. You see? There is no way I can see the old signatures. I need to run a script on PowerShell to see the duration. What do I do? This is for the design. What do I do if I think that could be a signature or signatures floating around that might compromise my security? We go to the access keys, go here, and we rotate the keys So whatever signature is using them will be now invalid. It won't work. We have two keys, you see? We can rotate them here manually as many times as we want and as often as we want. And we can automate the rotation using an automation account. So you see what I'm going with this, right? I can give you access for a temporary request, but we shouldn't use signature for a long-term access. Okay? First things first. Now, next thing that we have, folks, this is the first layer of security, the actual network layer. We can add, check this out, an endpoint. I created all my stuff, right? You saw me actually. I created the blob, I created the file share, we have everything right. I can go here and say, if you want to consume the content of this storage account, you need to connect to it via a specific network. The only way I will let you access is if your traffic comes from this network. Now the network is mandatory. So as I said, we don't need it at all for the actual business as usual. For security purposes, is a must. I click like this. I click enable. It takes like 2 minutes. Check out. And the only way anyone, including me, global admin, can access the data inside of this storage is if the request is coming from a specific network. So I click on add. You can see I have the endpoint now, and we're good. I click save. Let's wait a couple of minutes. So let's go to Azure. I'm just waiting for the configuration to kick in, so you see it in real time. I go to the storage account again. I go to the storage demo. There we are. We're good, right? I go to the containers. Remember I created the container, right? What happened? I'm the owner. I'm the most powerful user. I'm the almighty user of this subscription. What happened? I've been blocked because my transaction is coming from an IP that is not listed on the subnet that I just configured. That, my friends, is called a service endpoint. This storage account is now behind an endpoint. To come here, I need to go through a funnel web that will actually let specific IPs to be authorized. You can do this on every storage account. The benefit we have also as users, as global admins, we can still create stuff. Check this out. I can create another container, let's say container 2, and I am not blocked from that. What I'm being blocked is the actual access. So that means when designing, folks, that you can granulate the management and the consumption without trimming out the capacity of action. You can have someone dedicated to create, and then someone on that subnet, let's say marketing, using that subnet and the devices using those IPs to access and manage the actual content. This is a pretty common practice. You segment by networks and sub-networks, you use VPNs or you use peering, and the people who's supposed to access has an IP related to the endpoint. The people who's not supposed to access are still managers, but they cannot actually modify the network. That's a best practice. And the third option is the firewall. I already have a filter on the endpoint, but if I go back to the network and I add a rule on the firewall saying this IP mine is actually authorized, there we go. We wait again for it to begin. So again, Azure. Let's go here. Storage account. Containers. And I am back see, I still have the endpoint protection. None of you could access from an internet connection. I can because I added my IP as an exclusion or an exception to grant the access through the endpoint. But the endpoint is still in there. This is a pretty important principle of design. Okay? Highly recommended that you use them if needed. So that's another security feature we have. And the final one, well, I want to mention the other two. Over here. It's one of them is encryption. Remember I said we can bring our own keys, right? If you create your own managed key, but you didn't have it during the creation, no worries. We can come here and select the key that you want. Create it from a key vault. If we had a key vault, I don't think we have one. Oh, I don't. I can create a key vault. I can create my key, and I'll be the owner of the logic encryption key. Remember that we can go advanced and select the multi-tenant encryption. This is one option. And I can select what will be encrypted by me, what will be encrypted by Microsoft. This is a good option, folks, because you might, if you're using, especially if you're using a general purpose storage account, you may have different needs, right? You may have the need of a pretty advanced encryption with your own keys for the blobs and the file shares, but the QEs and the other stuff might not be actually that, let's not say relevant, but that critical. So you reduce the dependency of key. The encryption, remember, can be changed in some scenarios where you might want to bring your own key and then change it. And in some other scenarios, for example, the usage of the hardware encryption will be limited to one-time change. And after the modification, you are not able to change if the hardware encryption is taking place. Okay, so be careful, especially on the hardware encryption. Okay, so that's another thing that we have. And this, my friends, is our topic of the day. These are the first 2 days of class. Yesterday and today is one single topic. Tomorrow and Thursday we have 2 topics per day. So you will feel a little bit more content being pushed in 2 hours. But again, remember we have access to all the learning paths and content available in our links. Okay. We have complete our second lesson of the week. We are going to go and let me see if we have a question. Which is most secure security? Which is the most secure security feature to implement without affecting the performance? Yes, Chandrasekhar has a point here. We have so many options. So I suggest that you combine encryption with network control. I, as an architect working with 3 clouds for a long time, I suggest that reduce the usage of shared access signatures. Okay, the shared access signature is a good emergency or last minute call, but for a long-term design based on security, the network is the best practice first. Keep it private or keep it public with firewall control, or keep it completely private and then create exceptions. That's the best option, in my opinion, folks. This specific comment is not on behalf of Microsoft. Okay, and then, if possible, bring your own encryption key to add that extra layer. That encryption won't affect the end user experience because it happens backend before the transaction is committed. So it's seamless. Unless you have 10 million transactions of the same file simultaneously, it's the simplest thing happening. So I will say, Chandrasekhar, that that's the option. Okay, I mean, again, my opinion, but network control and bring your own key for the encryption. Important, folks, remember, there is no correct answer. Okay, when designing, there might be multiple options. That's what I will do as an architect. Okay, so any other questions you have, drop them on the chat. We still have 5 minutes. Thanks to you. So we have here the case study. You can see we have different types of files, right? We need to bring to the table here what type of data do we have? What is a media file? What type of storage do I need for media, for example? Okay, what do I need for PDFs? What do I need for documents? How will I store it? Okay, this is like part of the recommendation. I'm not gonna click next because on the next one I have the solution. I don't know why. That's how Microsoft gives the content. So I want to skip quite fast, and there we are. Remember, these links are all on the learning pad. Okay, and this is today's session for us folks. Questions, issues, or complaints, my friends? We have 2 more minutes before we're done. I would like to know if there is anything else that you might want to ask. Remember, just to wrap up, the last session starts in 33 minutes. There are no live discussions on that session. There is no voice nor presentation. The only thing we have on that session is the Q&A open in case you have any issues or something. Okay, the service endpoint, Max, opens to any type of traffic that might come from a VPN, an express route into the private network, and then back to the connection. The private endpoint works on softnet level, and it's only accessible by private traffic. You have to go softnet to softnet, VNet to VNet, use peering without going to the internet, and then connect to the backend. So the difference is where the traffic is coming from before being analyzed. Okay. For today, folks, yes, that's a great question, Kito. Give me 1 second. Thank you, Asim. Thank you very much. Let me show you here before we're done. Let me see if I can find it fast. Today, oh, this is here. Yes, we have 2 minutes. Enough time. And here it is. Oh, where is it? Why is it not open? I want to show you what we have covered. Let's see. There. So this is the AC305. Okay. Day 1, you can see governance, and you work for computing. Day 2 is non-relational, and you have to complete relational, that is the SQL one, okay, and integration, that is the Data Factory and Data Lake. Okay, so this is what we have. I'm gonna look for that one, Chandras, because I couldn't find it on the documentation. I promise I'll have it for you before the end of the week. Let me just figure it out where they have it because it's not on the solutions folder, and I want you to have the Microsoft official one, not mine. Okay, so I promise I'll get it, Chandras, on one of the next days, tomorrow or Thursday. So today, folks, you have here relational storage and integration solution. Okay, and tomorrow we will go for the application and the authentication. This is what I will be covering tomorrow during the session. Okay, so now you know where we are. We have to cover the next 2 lessons of the class. Okay, so tomorrow I'll get you the solutions of today's session, and I promise I'll get you all the solutions by the end of the week. I'll share the file with you so you can compare with your own diagrams and we'll have an idea on where you were. Okay, you were. My friends, that's all for the day. We have to wrap up the session because we have a timer and it will kill it itself. But thank you very much for joining today. I hope to see you tomorrow for the 3rd day of lectures, and I hope to see some of you on the Q&A. Remember, not live, offline, but we're there to help you with any questions you may have. Thanks to all of you. Thank you, Max. Thank you, Chandra. Thank you, all of you sending messages there. I hope to see you tomorrow. Have a great rest of your day. Get some rest. Get something to eat. Get something related to your time zone. So thank you very much, folks. Thank you again for your time. And I'll see you tomorrow morning for the day 3 of our class. Thank you, folks.